Section 6.2, Graphing in the Rectangular Coordinate System. This video will help you graph points in the rectangular coordinate system and graph linear equations by plotting points. Graph points in the rectangular coordinate system. We'll take a look at a definition here. The rectangular coordinate system is a two-dimensional plane in which the location of a point is given by an x and y coordinate. So basically we have this two number line set. We have this one number line going horizontally. We call that our x-axis. That gives us one dimension. Then we have another number line going vertically. That gives us our second dimension, and we call that one the y-axis. So the ordered pair 2, 3 identifies the location of this point with the coordinates x equals 2, y equals 3. So starting with the origin here, which is 0, 0, and we call it the origin because this is always the starting place for any of our points. So we're going to start right here, and I'm going to count in the x direction to get to this point up here. The x coordinate, or the x direction that we're traveling, is 1, 2 in the x direction, and then 1, 2, 3 in the y direction to identify that point on this coordinate plane. Let's take a look at an example now that will help you understand how to graph points on the coordinate plane. So I'm graphing the point. The first one I'm going to graph here is the point 2, 5. Notice every ordered pair, we call it an ordered pair. We call this an ordered pair because order in this pair of points makes a difference. The first point is always our x coordinate, and the second point is always our y coordinate. So to graph this point 2, 5, I'm starting at the origin, and I'm going to go over in the x direction, 1, 2, and then up 5 in the y direction, 1, 2, 3, 4, 5. And there's going to be the point 2, 5. Graphing the point negative 3, 2, I would go negative 3 in the x direction, 1, 2, 3, and then positive 2, 1, 2. So there's the point negative 3, 2. The next point, 0, negative 4. 0 meaning I'm going to move neither left nor right on the x-axis. I'm staying right here. And then I'm going to go down 4 for the y coordinate of negative 4. 1, 2, 3, 4. And the last point is negative 4, 0. So I'm starting at the origin, and I'm going to go left 4, 1, 2, 3, 4, and then no movement in the y direction. So I'm going to end up right there to graph those points. Go ahead and pause your video player now and answer practice question 2. When you're done, hit play to see how you did. Okay, so the point 1, 1, we should be over 1, up 1. The point negative 4, 3 should be left 4, 1, 2, 3, 4, and then up 3, 1, 2, 3. Negative 5, negative 2, we're going to move negative 5 in the x direction, 1, 2, 3, 4, 5, then negative 2 in the y direction, so down 2 to get that point. And then finally negative 3, 0, starting at the origin, I'm going to go over 1, 2, 3, and then I'm moving neither up nor down in the y direction, so I'm going to end up right there. Graph linear equations by plotting points. Let's take a look at a definition here. The graph of a linear equation, two variables, is a straight line. Linear equations are written in the following form. So all of the graphs we're going to be looking at now are going to make straight lines, no curves or arcs or bends or anything like that. They're all going to be straight lines. And they're all going to. And the first types of lines we have are diagonal lines. So those lines, in this case, this one is traveling downward. We could also have a diagonal line that's traveling upward, but basically not going perfectly vertical or perfectly horizontal. I'm calling a diagonal line here. When we have a diagonal line, we're going to have this type of form of an equation. Some number, a, times x, which will be our variable, and then this could be plus or minus, b, another number b, times y, equals some other constant number c. So equations that have both an x variable and a y variable in them are going to be diagonal lines. And here's an example of this one here. This is x plus 2y equals 4, and that's the equation of this line right here. So this equation, if I plot all the points for this equation, this is the line that it will create. The other type of line we can have is vertical lines. So these are lines that are traveling perfectly up and down. And so vertical lines always have this form. They only have the variable x in them, and they equal some number. So there's going to be no y variable at all. So when just x is involved in the equation, we are going to get a perfectly vertical line. And here is the equation for that one right there. 2x equals 10. Horizontal lines. Horizontal lines are, of course, traveling side to side here. And we're going to get a horizontal line when we have only the variable y in the equation. So y equals some number will give us a horizontal line. And so here's the equation of that one is y equals -2. So here's our linear equation, and what we want to do is we want to find the points and we want to graph this linear equation on our coordinate plane. So the first thing we're going to do is we're going to find some points. And I think the best way to do this is to make a t-table. The t-table here is just really a reflection of our points x and y, except when we make a table like this, it's easy to enter. We need 3 points here. So it's easier to enter them on a t-table. So here is our equation. 2x plus 3y equals 6. All I want to do is I want to find values for x and y that will make this equation a true statement. All right. The other thing I want to do is I want to make sure I stay on my graph. I don't want to have any points like 25 or anything like that, because notice the range of my graph, it goes from -6 to 6 in both directions. So I got to stay on my graph here. So I guess the first thing I'll pick here is I'll pick a value for x, and the first value I'll pick for x is going to be 0. I'm going to pick a 0 there. 0 is an easy number to substitute. So if I put a 0 over here in for x, it would look like this. 2 times 0 plus 3y equals 6. Well, 2 times 0 is just going to give me 0. So my equation really simplifies down to this. 3y equals 6. You could look at that and go, oh, y has to be 2. Or you could say, well, I'm not sure. Or if it maybe got a little more difficult and you weren't sure, you could just solve this equation. Divide both sides by 3, and we'd see that y is equal to 2. So I have 1 point here. I'm going to pick 3 points. So 1 point, so I need to do 3 more of these things. So maybe this time I'll try a 1 in there for x. So let's see, then I'd have 2 times 1 plus 3y equals 6. So let's see, 2 times 1 is 2, so I have this 2 plus 3y equals 6. Well, this one I can't see right away, so I'm going to solve this equation. -2, -2. Come over here, then I'd have 3y is equal to 4. Divide by 3. We get that y equals 4/3. This is going to happen sometimes. 4/3 is okay, but it's going to be difficult to graph that accurately over here on a coordinate plane. So I'm going to write that down. So we just tried 1 and we got an answer of 4/3, which is kind of not so perfect. It's okay, and we can use this as our checkpoint, which I'll show you in a second, but let's try some more points. Notice it was easy when I put a 0 in for x. I'm going to try now putting a 0 in for y. So then I'd have this 2x plus 3 times 0 equals 6. Well, 3 times 0 again is 0, so I end up with this 2x equals 6. That's going to be a nice value. X equals 3. So I have these 3 points. You know, this first point 0, 2, and this second point 3, 0. Those are my best points. This one here I'm going to kind of have to estimate 4/3. So let's take a look. Let's write this as a mixed number. So 3 goes into 4 one whole time with 1 left over. So that is really 1 and 1/3. Let's go ahead and graph these points now. I'll start with these two. 0, 2. So 0 in the x direction, up 2 in the y direction is that point. Then this next point, 3, 0. 1, 2, 3 is right here. Okay? So the line is going to travel just like this, according to these 2 points. Now it only takes 2 points to make a straight line. So all I really need to have here is 2 points to make a straight line. We use this third point as a checkpoint, because if we made a mistake with 2 points, we could graph the line and turn out just fine. But if we use 3 points, and let's say when I graph this point, this is not the case, but if I graph this point and it ended up being here, you know that somewhere you made a mistake, because notice this is no longer making a straight line. Like this, I've got this weird diagonal and weird lines going in different directions. So that's what the third point is for. It's just a checkpoint. So let's go ahead now and use this as our checkpoint, because even though it's not a nice clean one to graph, it's going to work fine for a check. So I go over 1, up 1 1/3, which is about right there. And so notice that point lines up nicely with our other points. So when you get to 3 points that line up like that nicely, you know you've not made a mistake, and you know that you're ready to go ahead and graph the line. So I'm going to go ahead now and connect these 3 points, the straight line. And I use a little straight edge here. It's a good time to use a straight edge. You can use a ruler or the edge of a credit card or something like that to make a nice straight line. And notice I want to put arrows on the end of each of these lines because that says this line continues on forever. Now, notice what this line is going to represent. Notice when I graphed this line, 3 of our solution points were on that line. Well, in fact, all of the points on this line are going to be a solution to this equation. Go ahead and pause your video player now and answer practice question 4. When you're done, hit play to see how you did. All right, practice question 4. Making ourselves a t-table, x first, y second. I think 2 easy points to try here is 0 for x and a 0 for y. So let's put a 0 in for x. When I put a 0 in for x, I'd have this 2 times 0 minus 3y equals 6. So 2 times 0 is going to give me 0, so I'm left with this. Negative 3y equals 6. Divide both sides by negative 3. And then you get that y equals negative 2. So there's that point. Now I'm going to try a 0 for y. So notice negative 3 times 0, that's going to give me 0, so I'm left with this. 2x equals 6. And you can see right from there that x is going to be 3. Now let's find a third point to be our check. So now I'm thinking, what can I take away to end up with 6? Notice if I put a 1 in here for y, I'm going to be subtracting 3. And so this is always going to be an even number. And this is always going to be 3, you know, because 2 times any number is going to give me an even number. Well, I'm not going to be able to get to 6 by subtracting 3 from an even number. So I'm thinking, all right, 1 is not going to work there. What if I put a 2 in there? Then it would be basic like this. Then I would be subtracting a 6. That's what would happen. If I put a 2 in there, I'll be subtracting a 6. And I'm thinking, okay, 12 minus 6 will give me 6. So now I'm getting close to getting to this, this third point and having it work out nice. So what could I put in here for x so that this would end up being 12, so I'd have 12 minus 6 to give me 6? Well, the answer to that is 6 itself. So that's going to be one of our points here. 6 for x, 2 for y. Let's go ahead and check that out now. 2 times 6 minus 3 times 2 equals 6. Well, let's see. 2 times 6 is going to give me 12. 3 times 2 is going to give me 6. And sure enough, that's going to work. That's going to work as my third point. So let's go ahead and graph these. So over 0, down 2. That's my first point. The next point is over 3, up 0. And my last point is over 6, up 2. And you'll notice I'm getting a nice straight line with those dots. So I know I've not made a mistake here. So I'm going to go ahead and get my straight edge out. Put some arrows on the end. And we've graphed that problem. So one way to work smarter when we're graphing linear equations is to pick values for the cluttered variable. And so for example here, here's a linear equation, has both an x and y in it, so this is going to give us some sort of diagonal line. But notice the y is all by itself here, and the x is kind of cluttered. I'm calling that cluttered. It has other things going on here. It's getting multiplied by 6. So when something like this happens, where you have one variable all by itself and the other one kind of cluttered, pick your initial values for the cluttered one. So if I come over here with a t-table, you see what I'm talking about. I put a 0 in for x, maybe a 1 in for x, and a 2 in for x. And I'll try even another point just to show you how easy this is. Because notice when I substitute this 0 in here for x, I'm going to go, okay, well, 6 times 0 is 0. And then that gives me immediately the answer for y. So I can almost do this in my head. If I put a 1 in here for x, I'm going to get 6 times 1, which is just 6. When I put a 2 in there for x, I'm going to get 12. When I put a 3 in there for x, I'll get 18. So notice if you pick for the cluttered variable, you can almost kind of do these things in your head and come up with these points very quickly. Okay, go ahead and pause your video player now and practice this idea and do practice question 5. Again, pick for the cluttered variable here and it will make the graph a lot easier to identify. All right, so let's take a look here. Make my t-table. Notice x is my cluttered variable here. I'm multiplying it by 4 and then subtracting 2 from it. So I'm going to go ahead and put some values in there for x. So let's try 0, 1, 2. So if I put a 0 in here for x, notice I'm going to get 4 times 0. Okay, So here's what happened when I put a 0 in for x. I'm going to get 4 times 0, which is 0, and then 0 minus 2, well, 0 minus 2 is negative 2. So I quickly get my y value there. Now, I'm going to put a 1 in there for x, and let's see. 4 times 1 is 4. 4 minus 2 is 2. And then when I put a 2 in there for x, I'm going to get 8. 8 minus 2 is 6. So there are my 3 points. So notice by picking for the cluttered variable, I came up with those 3 points very quickly. So let's see, 0, negative 2, over 1, up 2, and then over 2, up 6. So a very steep line here. It's traveling uphill very quickly. But notice they're all lined up in a row, so I know I've not made a mistake here when I was coming up with those points. So another way to work smarter when we're graphing linear equations is to pick multiples of a fraction's denominator if you have a fraction as in part of your equation. So notice we've been solving everything up to this point with whole numbers, but now we've run into this equation y equals 2/3 x plus 1. Well, whatever value I put in for x, I want to make doggone sure it's a multiple of 3. And remember, multiples of 3 look just like this. 3 times 1, the answer to that is 3. 6, 9, 12, ... Those are the values I want to put in here, because if I put those values in here, the fraction's going to go away. Let me show you what I'm talking about. So y equals 2/3. If I put a 3 in here for x, I'm going to have this 3, and I'm going to write that as a fraction since I'm multiplying it by a fraction. So I'm writing it as 3 over 1 plus 1. And notice these common factors of 3 are going to divide right out for me, get rid of the fraction, and so I'm left with this, y equals 2 plus 1. So then I would have my ordered pair then, 3, and then 2 plus 1 is 3. So that gives me the ordered pair pretty quickly. And notice if I put a 6 up here, this 3 would divide out. It would leave me a 2 up here, but it would still divide that denominator of 3 out. And once we divide the denominator of 3 out, we're not going to have fractions anymore in our problem. So anytime we're working with an equation and the cluttered variable has multiplied by a fraction, pick multiples of this fraction's denominator, and it will clear the fractions right out of the equation for you. Let's go ahead now and practice this idea. Pause your video player and graph this equation. All right, so notice my cluttered variable again is x, so I want to try picking values for that, but notice it's getting multiplied by 1/5. So I want to multiply by multiples of 5, which are 5, 10, 15, 20. Well, 5 is a good one. That's no problem because that's going to end up on our graph, right? On the scale of our graph. But 10 and 15 and 20, those are getting way too big to end up on our graph. So here is what I'm going to do. Multiple of 5. 5 is a good one, so I'm going to pick that. Notice these are just the positive multiples of 5. I can also choose the negative multiples of 5. So I also want to use negative 5 there. That gives me 2 points. Now I want a third point. Well, another multiple of 5 that's not listed here is 0. 0 is a multiple of 5. 5 times 0 is 0. So that's the third one I want to use to get my points here. So now I'm going to go ahead and plug these in. So y equals 1/5 times 5 over 1 minus 2. Notice 1/5 times 5 over 1, that's just going to give us 1. So I have this really, 1 minus 2. And so I'm going to get negative 1. So my first point is 5, negative 1. Now I'm going to plug a negative 5 in there. So I'll have this y equals 1/5. Again, I'm going to write that as a fraction, negative 5 over 1 minus 2. And let's see, 1/5 times negative 5 over 1, well, that's going to give us negative 1. And so negative 1 minus negative 2 is going to give us negative 3. Last one here, y equals 1/5 times 0 minus 2. Well, this is going to be nice because 1/5 times 0 is 0. 0 minus 2 is negative 2. And there are my 3 points. So over 5, down 1, left negative 5, 1, 2, 3, 4, 5, down negative 3, 1, 2, 3. And my third point is 0 to the left or right, down 2. And you'll notice all 3 of those dots are lining up for me, so I know I've done this correctly. So I get out my straight edge. So I missed a little bit. So there's the graph of my line. Go ahead now and pause your video player and answer practice question 7. Notice here I'm going to have you graph two equations, y equals -3, and then a second equation, x equals 5. Notice I mentioned this earlier in the video, so you might want to scroll back and see what these kind of graphs are going to, or these kind of equations are going to look like when they get graphed. Go ahead and pause your video player and answer this, and then when you're done, hit play to see how you did. So remember, as I mentioned before, that a graph of y equals some number is always going to be a horizontal line. Okay, so y equals, in this case, -3. If we come down here, 1, 2, 3, here is where y equals -3. So all of these places here, this is where y equals -3. So we are going to end up with a line coming right across like that for the graph y equals -3. Another way to think about it is this, that there's only restrictions here with this equation y equals -3. The only thing that is being restricted here is y. So if I came over here and made my t-table x and y, I can put any numbers I want on my x side. I could put like 1, 2, 3, 4, and 5 for my x side, but y is going to be -3 every time. And you'll notice that's what I've gotten here. If I go over 1, down -3, over 2, down -3. Notice I'm still getting all of these lines to make this horizontal, getting all these points which will make this horizontal line. I'm saying this and I'm mentioning this now is because it seems like students always get these confused. They know that this equation here and this equation here are going to be either vertical or horizontal, but they forget which one. And so if you're in that situation, you forget which one, you can make yourself a little t-table to help you remember. For here, y is always going to be -3. So there's all the -3s. There are no restrictions on x, so there's going to be any number we want to put in here. If we look at the graph of this one, x equals 5, notice there are no restrictions for y. So it's going to be this. X is always 5, no matter what value I want to pick for y. And so this will look like this. To the right 5, up 1, up 2, up 3, up 4. So notice you're going to get a vertical line right there for the x. So if you can remember that y is always horizontal and x is always vertical, that's great. If you forget, go back and make yourself a t-table, and you'll be able to get the answer real quickly.